This presentation discusses KSP and molar solubility of both soluble and insoluble salts. KSP is the solubility product, so if we have a salt, let's call it AB, we can write its dissociation as AB is in equilibrium with A plus and B minus ions. So its equilibrium constant would be the ratio of products over reactants, but since the reactant is a solid, it is not included in the equilibrium expression. So we just write KSP is equal to A minus times B plus. So any time you have a small KSP, that means the solid is not very soluble. Molar solubility S, or sometimes X if you're using an ice table, just refers to the moles of salt that will dissolve per liter of solution, so it's the concentration of the ions. So you can directly compare the extent to which two different salts will dissolve into solution, because this quantity is not dependent on stoichiometry. In this lab, we will be titrating to solve for the molar solubility of potassium bitartrate. Potassium bitartrate is a mildly soluble salt that's in equilibrium with potassium ions and bitartrate ions in solution. So we can find the equilibrium concentration of bitartrate ions by titrating the solution with sodium hydroxide. We know that the moles of OH- are going to be equal to the moles of bitartrate in the original solution. So now we can fill in an ice table and solve for KSP. We are going to use our ice table to solve for KSP. We know that the solid is not included in the ice table, so we have bitartrate and potassium. Initially we don't have either one in solution, but we can use the data from our titration to figure out the equilibrium concentration of both. So let's practice. If it takes 9 milliliters of 0.1 molar NaOH to completely titrate 10 milliliters of our solution, what is the concentration of bitartrate in the sample? This will also be its molar solubility. And what is the KSP? So the first thing we need to do is solve for moles of our titrant. So if we have 9 milliliters times 0.1 molar, that's 0.0009 moles of OH-. We know that the moles of OH- are equal to the moles of bitartrate, and the molarity of bitartrate is just moles divided by volume. So we have 0.0009 divided by the 10 milliliters that we took, and we get 0.0900 molar bitartrate. So now we want to find the KSP, and that's just the concentration of K plus times bitartrate, so both of those should be equal to each other, and we get 0.09 squared, and that is equal to 8.10 times 10 to the minus third. So we found both the KSP and the molar solubility for this salt.